Hello YouTube, this is Emails03. In the previous lesson, we learned about something called a linked hash map. Okay, we've already been starting to discover that there might be more than one data structure that is similar. Okay, so when we talked about hash maps in lesson 55, we also brought up later on a hash table. Okay, when we talked about array lists, we also ended up bringing up a vector. When we talked about queues, we also ended up bringing up a concurrent linked queue. When we talked about hash sets, we also ended up bringing up a linked hash set. When we talked about hash maps, we ended up bringing up a linked hash map. So now there's three types of dictionaries that we have available to us. We have a hash set, we have a hash table, and we have a linked hash map. There's a fourth type of dictionary that we're going to learn about in this video, and it's called a concurrent hash map. And we've already seen the word concurrent before when we were talking about concurrent linked queues. But we can go ahead and study review some of what we had when we were talking about linked hash maps. So we said there are at least three types of dictionaries, and we're going to be adding on another one in this video. So there's another one in this video called a concurrent hash map, and that's going to be lesson 69. But what we could do is we have to go ahead and remember to import java.util.linkedHashMap, okay? And then if we want to iterate on it, then we have to say import java.util.iterator, okay? And then we could say linked hash map of integer and double my dictionary equals new linked hash map of integer and double. And then remember, we added 5 key value pairs to the dictionary. It turns out two of the key value pairs are the same value, which is fine because we said the keys in a dictionary have to be unique, but the values in a dictionary don't have to be unique. And then we said my dictionary.remove of -8. So like we saw in the previous video, if you call .remove on a particular hash map or hash table or linked hash map, then you just pass in a key, then it would remove the key value pair for that particular key. And then what if you say my dictionary.replace of 2 with 22.222? So now 2 is no longer assigned to 81.01. And then my dictionary.replace of 10, 15.5, 19.5. So then I guess we'd have to adjust the comment here, but this says it only reassigns the value associated with key 10 to 19.5 if the current value is 15.5, and it is. So it turns out that we actually end up modifying both of the key value pairs that initially had 15.5 as the value. But then if you say iterator of type integer my keys equals my dictionary.keyset.iterator, and then I guess we have to just go ahead and maybe we deleted the example, but what we could say is while my keys dot has next, I guess this is on the, yeah, so then we would say system.out.println of my keys.next, okay? And so that would just give us each of the keys in the linked hash map, and you could do that with hash maps in general and with hash tables, okay? And so you just get 0, 2, 3, and 10, because remember we removed the key value pair -8, so hopefully that's clear to you. And then what if you said my dictionary, dot get of my keys.next? Okay, so then what we can do is we could say compile, and then we can go ahead and run it. And you could say you would just get the 4 values. You get 66.2, 22.222, 94.5, and 19.5, because the other 15.5 was removed. So hopefully that's clear to you. And that's how a linked hash map works. And so we've been comparing and contrasting different data structures that we've had available to us, right? We've talked about so many of them, right? So we talked about an array list, we talked about a linked list, we talked about a stack, talked about a queue, hash set, hash map, and then we sort of have the more legacy ones, so the ones that don't really matter as much as long as you have it. So these are like the, I guess, the essentials, and then these are, and then you could call these additional data structures. Okay, and so which ones are we talking about? So vector, so then array list, this was like lesson 27 or 28, I think, and then this was like 50 and 51 for linked lists. This was 52, 53, 54, and 55, and then vectors talks about 59, hash tables was 64. Okay, and then we're studying these other ones, right? So we talked about a concurrent linked queue, that was 66, and then we talked about a linked hash set, and so that was 67, not 78. And then we also talked about a linked hash map, so that was 68, and now in this video we're going to be talking about a concurrent hash map. So you first thought that there were only 6 data structures available to you, but there's actually 12. Okay, and so there are actually 12 data structures. Okay, because you essentially have 2 array lists. Okay, and then you have 1 linked list, and then you have 1 stack, and you have 2 queues, and we talk about 2 types of sets, and now we're going to be talking about 4 types of maps. Okay, we're going to be learning about the 4th one in this video. Okay, and then we can think about what types of iterators and enumeration and list iterators available on each of these, right? But this would be iterator and list iterator. Okay, and then this would be the same thing. So it's just another type of list. So iterator and list iterator. And then with stacks, they get a little bit more. So they also get the enumeration too. Okay, and then with queue, you only get an iterator. With a hash set, you only get an iterator. And with a hash map, what do we get? So we can have an iterator on the keys, on the key set, or iterator on the values. Okay, and the same kind of thing happens for these legacy data structures as well. So if you do hash map, this would also apply for hash table. And I think we also said that you can do an enumeration on the elements, and so that would actually have the effect of enumerating on the values. I think we saw that in a previous video, right? But then in a vector, you get all 3. So you get iterator, list iterator, and enumeration. Okay, with a concurrent linked queue, you only get an iterator. Okay, with a hash set, with a linked hash set, you only get an iterator. Okay, just like with a hash set. With a linked hash map, again, it's just going to be an iterator on the key set or an iterator on the values. Okay, so that's just going to happen here. Not for that one. It's going to be for this one. Okay, and it's going to be similar for concurrent hash map. So it turns out that we're going to be able to do an iterator on the key set or an iterator on the values. But do you want to iterate through the keys or the values? Okay, you could iterate through both at the same time, and we're going to think about how to do that in this video. But this is what we've been saying about data structures. And now we've learned about linked hash maps, and it's just like hash map, but it's just another way of doing something similar in Java. It's just another dictionary that you have available to you, right? It's fun when you have more than one way to do the same thing in a programming language, and then you can also use a little bit of personal preference or discretion. But the linked hash map is going to do a couple extra things. It has a couple extra specific aspects of it that you wouldn't see in the hash map superclass. But the set of methods, the collection of methods that you have available to a linked hash map is very similar to the collection of methods that you have available to a hash map in general. The collection of elements that you have available to a linked hash set is very similar to the collection of elements that you have available to a hash set in general. What we're going to do in this video is talk about another type of dictionary. Okay, so we've already learned about hash maps, hash tables, and linked hash maps. Let's learn about a 4th dictionary. So we're going to learn about another type of data structure that can hold key value pairs. And the keys in a concurrent hash map have to be unique, but the values in a concurrent hash map do not have to be unique. But you have to say concurrent hash map Java, and we can go ahead and study what it is that this class does. And so you can see this is the class hierarchy. So we start at object, and then one down from that is abstract map. And then the very next one is concurrent hash map. And it looks like we're going to need this .concurrent again. So one of the things we can do before we get too deep into this is we need to say import java.util.concurrent hash map. Okay, so this enables you to create a concurrent hashed map in your Java file, in your class. Okay, and so, but you have to have this .concurrent. Okay, it's not java.util.concurrent hash map. It's java.util.concurrent hash map. Okay, so hopefully that's clear to you. And now there should be no issue with creating a concurrent hash map. And one of the things we actually could do is, instead of just writing the word linked here, we could write the word concurrent. And so we're literally just going to change the data type of this hash map. And the class totally compiles still, right? We literally changed 2 words. We literally just took our linked hash map example and turned it into a concurrent hash map example. So we're going to say concurrent hash map of integer and double, my dictionary, equals new concurrent hash map of integer and double. And then we add these 5 key value pairs to the dictionary, and then we're going to remove this -8, right? We've already talked about this, but the point is that the linked hash map and the concurrent hash map are very, very similar. And so this is a hash table supporting a full concurrency of retrievals and high expected concurrency for updates. So we had 1 or 2 videos about threading, and we said that there's basically this aspect of computer programming called concurrent programming. And that's basically when you're trying to execute multiple tasks on a data structure and object at the same time. And in some cases that can be permitted, in some cases that can be preferred, and it can help you save time if you have Java dealing with multiple aspects of a data structure at the same time rather than one at a time. But anyway, we're going to study about a concurrent hash map, okay? And so it's just like a hash map, okay? And so this is very, very similar. So you can see these words hash table and hash map are appearing over and over again. So you can see it's doing some comparing and contrasting. Presumably these classes have distinctions, right? They're not identical, but they're referencing each other a lot. They have to be similar. They're sort of in the same clan. But you can clear a concurrent hash map. You can see if a concurrent hash map contains a particular key or value. You can return an enumeration on a concurrent hash map, and that would enumerate on the values in the table. And so that's probably something we can add to our notes up here, but we could say an enumerator. So I guess this will be a little bit more like a hash table rather than a hash map, right? Even though it has hash map in the name, it seems like it actually works a little bit more like a hash table, because with a concurrent hash map, you can enumerate on the elements, but we said that's really not that useful of an operation because an iterator performs better anyway and has shorter method names. But those are the 3 types of iterators I guess you could perform on a concurrent hash map. You either iterate on the keys, you iterate on the values, or you enumerate on the values. And so we can go ahead and see some different examples, right? What if we wanted to do, what if we do enumeration? And so now it's just going to be double because it's going to be on the values. And so you would say enumeration of type double, my values, and then you would say you would just say my dictionary.iterator, okay, because it's called directly on the dictionary, okay. And so it wouldn't be an iterator, it would be elements, right? So you'd say enumeration of type double, my values equals my dictionary.elements. And it's not called my keys anymore, it's called my values, okay. And then you wouldn't say my dictionary.get of a particular value. You would just return the value. So you would just say has more elements, right? Has more elements. And then instead of calling .next, you would have to call .next element. So it's a little bit of a review of enumerations. But we said the only 2 differences between an enumeration and an iterator is that an enumeration has longer method names and does not support a remove operation on the underlying data structure. And you would say my values.next element. So system.out.println of my values.next element. And presumably we should be able to enumerate or iterate through the values in the concurrent hash map. So we added 5 key value pairs to the concurrent hash map, but then we removed the key value pair associated with the key -8. And then we replaced the other 15.5 with 19.5. So then if we go ahead and compile it, and then we go ahead and run it, we get very, very similar output. So we just get the 4 values in the concurrent hash map. So hopefully that's clear to you. And that's just how these methods work. And you can also clear a concurrent hash map. You can see if a concurrent hash map contains a particular value. So what if you say system.out.println of my val, or you would say my dictionary. My dictionary.contains key of 1, or my dictionary.contains value of 66.2. Okay, so at least one of those booleans is true, which means that the OR statement would evaluate to true, right? So then you go ahead and print true there on the console. But then what if you go ahead and say and? What if you say my dictionary.contains key of 1 and my dictionary.contains value of 66.2? So then you go ahead and compile it and you go ahead and run it and you get false, right? I guess we still have 6 more minutes. So what else can we talk about? We could see if a concurrent hash map contains a particular value, okay? And it seems like it performs awfully similar to the contains value method, right? And so with contains, it says testing if some key maps into the specified value. Like, do we have our value in the dictionary and the concurrent hash map? And it seems like it works almost the same way as the contains value method. You might just be better off writing contains because it's shorter, but it says legacy method, okay? So if we click on it, it's a legacy method, okay? And it says that this method is identical in functionality to the contains value. And it exists solely to ensure full compatibility with the class hash table, whatever. but it's just another another option. So you could have just said contains of 66.2. It's just two methods that do literally the exact same thing. And so you could just go ahead and run it, and it just says false. And so those would always return the same thing, contains or contains value. If you're asking if an element is contained in the dictionary, by default, we think that you're talking about the element as being one of the values, right? If we're saying if it does a dictionary contain something, by default, we're talking about looking in the values. So hopefully that's clear to you. And then we can also think about what would be the size of this dictionary. So then let's just remove the enumeration. But what if we say system.out.println? What if we want the number of elements, the number of key value pairs in the concurrent hash map? So then you would just, on your particular instance of the concurrent hash map class, you would say system.out.println of whatever you call it, like my dictionary, for example, dot size. And that would just return the number of key value pairs in the dictionary and the concurrent hash map. And presumably that would be 4 after we add 5 key value pairs, but remove one of them. So hopefully that's clear to you. And then we can also, it looks like there's also a toString method. So one of the things we've talked about in previous videos is that there's a toString method. Okay, so we can think about what a toString method does. So what does it mean to print a concurrent hash map, right? We've already talked about how if we create a person class, it would and we try printing an instance of our person class, it would return the hexadecimal representation of the hash code of the object. But here we can return a string representation of the concurrent hash map, and it would consist of a list of key value mappings in no particular order, enclosed in braces. Adjacent mappings are separated by the characters, and then we just also have equal signs connecting each key to a value. So that's kind of a standard way that you would see a dictionary. Okay, in Python, when we talk about dictionaries, I have a whole collection of Python videos. If you are not bored of programming yet, you can go watch another 65 or 69 videos. But in Python, it's usually a colon between the key and value. So maybe you've seen that before, but it's like key colon value rather than like key equals value. But anyway, let's just try printing our instance. Let's say system.out.println of my dictionary and see what the output would be. So then if we go ahead and run it, we get 0 equals 66.2. So it's not really equals, but it's just saying that you're going to assign each of the keys to a particular value. And that's how Java decides to give you a string representation of a concurrent hash map. Okay. And there's other methods that you have available to you. There's also a method called, let's think about another one. So there's also a method called put all. Okay. And so it turns out that you could actually put all of the elements from another hash map or linked hash map or concurrent hash map into an existing concurrent hash map. So let's think about what we would do here. So this says basically what we'll do is let's create a linked hash map, and we're going to add elements onto it. So we're going to say linked hash map of type integer double. And let's just call it potato equals new linked hash map type integer and double. Okay. And then what we're going to do is we're going to say potato.put of 15 and 15.2, potato.put of 90 and 86.3, and then we could say potato.put of 102 with 103.3. And then what we're going to do is we're going to say my dictionary.putAll of potato. Okay, and so what this would do, basically what the putAll method does, putAll is a void instance method called on a concurrent hash map. Okay, and what it does is it adds all key value pairs from the input dictionary into the dictionary on which the method is called. So then if we print the string representation of the concurrent hash map, after we've added these 3 new key value pairs to the dictionary, hopefully you can predict what we would get. So we would just have a larger collection of key value pairs, because now there are a lot more key value pairs in the concurrent hash map. So hopefully that's clear to you. What if in the map that we were merging in, we had a duplicate value or duplicate key, right? So we already have a key value pair with a key 3, but then we're going to try to add another key value pair with the key 3 again. So let's figure out in the resultant concurrent hash map what the value is going to be associated with the key 3. So then if we go ahead and run it, we get 15.2. So then the effect here is that it replaced the value associated with that key after you called the put all method. So hopefully those concurrent hash maps are interesting to you. It's just another data structure. From Emos03, thanks for watching, and please subscribe.